Yes, Prof. So I have asked the participants to ask their questions because you've responded to most of the Vula Forum questions. So I think they can go ahead and ask their questions. And in 5 minutes, their session will end, and then the group 2 will join. So we can continue to respond to the questions. They will still get the recording.
I would just want to show, okay, they have one question. You want to know how to get rid of the extremities. I will show them one of the slides here. After making the multiple sequence alignment, let's see, for example, I did multiple sequence alignment using muscle. For example, here, you can there is some portion of your alignment that aligned very good in a very good and really, I mean, can find out a very conserved domains that between your sequence. And also you have other parts which I just show in arrow number 1 and arrow number 2. These two parts have to be removed because it's in the extremities and not aligned very well. Just delete that part which is in the extremity, that especially I'm talking now about DNA. Usually in DNA, you can just get rid of these parts that not align very well between the sequences, and also only use that conserved part. So, so by that, you can, of course, after this, can extrapolate other information. This, of course, depending on what you're going next, what you will do next with these sequences. So you get rid of that extremities. You can do the same thing with JAL view. Just slides only to show you why we do that. We do it very easily by any program. You can do the same thing with MEGA. You can do the same thing with JAL view, which you already studied, and get rid of the extremities and only use the conserved part or conserved domain. If there is no difference, this is for the DNA. If there is no difference, and they all start the same start for the protein, for example, don't do this. You don't need to do this. So for protein, no problem. You can all of them start at the same position, which is methionine, and then you can do the alignment, and of course you can extrapolate the phylogenetic relationship between your sequences, for example, or extrapolate the 3D structure. Depending on what you will do, you will go next. As I told you, multiple sequence alignment is a very important step, key step for going ahead in different application in bioinformatics. So what you want, why you do the multiple sequence alignment, and what you want to get next. This is a very important question you have to keep in mind, because this will determine where to go. Exactly. Thank you very much for thanks for listening.
Thank you, Group 1, for joining us. If you haven't asked questions with regards to today's session, don't stress. When the session 2 groups join, I will ask them to go back to session 2 and ask questions related to session 2 so that they be recorded onto this session recording. And then you can go through the Q&A at your own time so that you understand what you need to do for session 2. Thank you for joining us for today. Prof will resume it at 15:45 for the group 2 session to join.